All right, so as I said earlier, I was going to go through these notes. This is the definition, derivative of inverse functions. Inverse functions don't come up very often. This is probably, out of all the topics that we're going to discuss, the one that I feel kind of the strangest. I feel like I finally maybe came up with something that will work, but not necessarily one of the best things that I've got yet. So it's kind of a tricky thing. So let's go through, and we'll do the best we can with it. And what I'm going to do is I'm going to graph inverse functions. So first off, an inverse function, f of x is equal to x third, g of x equals x to the 1 over 3. And one of the things I want to make abundantly clear is remember that if we talk about, well, let's deal with inverses here. First, we'll go ahead and we'll graph them. 1, 1, 2, 3, 4. I'm definitely not going to get, actually I go 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And we'll go down 1. All right. So if I were to graph the function f of x, which is x to the third, we would have points like -1, -1, 0, 0, 1, 1, and then we would go all the way up to 2, 8. And we should know from experience that this graph looks something like so. Wow, that's a really terrible graph. Let me try to draw a little bit smoother curve. There we go. That's better. And this would be, this function obviously increases, this would be our f of x function. If I were to graph the inverse x to the 1/3, we find out that I still go through 0, 0, I still go through 1, 1, I still go through this, but then I go to 2, 8, way the heck out here, and we get a function that looks something like this. And if you don't believe me, you can graph this with your calculator and you can look at a table of data. But you would get some sort of graph that looks like that. So if we think about inverses, one of the things we need to remember is that in an inverse function, that really, if I were to take these curves, and if I was to take this f of x and reflect it over the graph of y equals x, over that line, we would get the function that the x's and y's flipped. You maybe have talked about that before, that if I wanted to find the inverse function, I take the x and y, I reflect them over each other, so the x's becomes y's, the y's become x's, and then we wind up solving to get the y by itself. The other thing I want you to remember is that by definition, if I take the f of g of x, in this case, if I take x to the third, but I actually do x to the 1/3 to the third power, we just get x. And that is a definition of an inverse function. That if I take the f of g of x, if I take the f of the inverse of the same function, we wind up getting x. They undo each other, and whatever the argument is, that's what I have left. So if I want to calculate the slope of f at these points, 1, 1, 2, 8, and 327, the first thing I need to do is I need to be able to realize that f prime of x is 3x squared. So if I want to evaluate these, I'm going to create a small table here. I'm going to have x and I'm going to have f prime of x. Then at 1, 1, and 2, and 3, at 1 we would have 3 times 1 squared, which is 3. At 2 we'd have 3 times 2 squared, which is 4 times 3 is 12. And if we do this, this becomes 3 times 3 squared, which is 27. And we can see that we get these slopes. On the flip side, if I take g of x, remember g of x is x to the 1/3, and if I find g prime of x, we would get 1/3 x to the -2/3, or 1 over 3x to the 2/3. This one's going to take a little more work. If I want to find g prime of 1, again, I'm going to come up with a table. Now, because this is such a cramped problem, we've got 1, 8, and 27. And realize that the point 1, 1 corresponds with the point 1, 1. Remember, we're doing this x flip thing. It's x and y flip. So the point 2, 8, its inverse is going to be the point 8, 2. And that the point 327, if we think about the inverse point, we're talking about the point 27, 3. Remember, we're talking about x and y flipping with each other. Then what we can see is if I substitute these three things, and I'm going to do the work over here, so just kind of in a random spot. 1 over 3 times 1 to the 2/3 is just 1 over 3. So when x is 1, I get a slope of 1/3. If I do 1 over 3 times 8 to the 2/3, what I ask myself is, what is 8 to the 1/3? And the cubic root of 8 is 2, so this becomes 1 over 3 times 2 squared. 2 squared is 4 times 3 is 1/12. And if I do 1 over 3 times 27 to the 2/3, the cubic root of 27 is 3, and I get 1 over 27. And when we look, what I hope you can see and what you can observe is that there is a relationship between these. And that relationship is that whatever I got for f of x, the point that we're correlated with it, so when the x is 1, we're dealing with 0.11, that reflection is the same point. 3 becomes 1/3. When I talk about the point 2,8, the reflection 8,2, the slopes are reciprocals. I go from 12 to 1/12. If I talk about x is 327 on f, then we're talking about the point 27,3 here. And if we look at that point that correlates with each other, I get a reciprocal slope. That goes actually back to an interesting thing. When we talk about f prime of x, and we talk about taking the derivative, remember that we said that f prime of x is dy dx. Well, if we think about the inverse, and if we think about the derivative of the inverse, if we let this be an inverse of f, remember that we've said the x's and y's can rotate around each other. Like the x becomes the y and the y becomes the x. So if we talk about that, then g of x really just becomes the dx dy. Well, what is that? That is just a reciprocal of each other. So that's how we get to that point. It's right about here where things get screwy. So, definition of a derivative of an inverse. If we let f be a function that is differentiable on an interval, we're going to let f be a function that is differentiable on an interval I. If f has an inverse function g, then g is the differentiable at any point, at any x for which f prime of the g of x is not equal to 0. So, part of that is that reciprocal dy dx thing that I talked about earlier. And the derivative of g is equal to the derivative of f at that g of x value. So that the f inverse of f derivative, let me show you kind of how that comes up. And then what's going to happen is I showed you all that, we've talked about all that, and then I'm going to throw it all away and show you a process. But I want you to at least see the proof so that you can see it to be able to work it. So this derivative function right here actually can be gained from the relationship that if I have the f of the f inverse of x, then that f of f inverse cancel each other out, and that gives us the x. If I take that, and I take the derivative of this, then what we would do is we'd realize this is a chain rule. The derivative of f is f prime of the f inverse of x times the derivative of the inverse of f. Now this looks really weird. This is the inverse of f prime x, because I don't want that to look like a double prime, and that should equal 1. And we're trying to figure out what is the derivative of the inverse. So if we want to get that by itself, we simply divide the f prime of the inverse at whatever that x value is. Now that's all cute and good. There's a whole bunch of stuff here to it, and I could go through and discuss it and how it all implies, but what I'm going to do is I'm going to use the example to help that. So I'm going to show you a little trick. Normally I'm not a process guy, but it's a little trick that shows an understanding between x and y for an inverse to make this wind up working the best that we possibly can. So what I want to do is I want to realize that x and y, I draw these little like weird tree trunk things where I've got this f of x and I've got my f inverse of x. And you're going to draw this stupid little tree all the time, because realize that this is just reflected over this y equals x line. And what the problem wants me to do is it wants me to find the value of the inverse of 25. So we could get the y and the x and flip them around and do all that solving. But we can actually do this problem without dealing with that. So they want me to find the value of f inverse of 25, and they want me to find the derivative of the inverse at 25. So I know that I've got some value here. I've got a point on my inverse that is 25 comma something. I've even got to find that something. if I want the point that correlates to this 25 comma something on f of x, then what I would do is I would realize that the x and y are reflected over the equation y equals x to give me the point something comma 25. What is that something? And how do we find it? Well, we could again try to find the inverse, but I don't want to have to do that work. But I can realize though is that this is f of x. So if I have something comma 25, I'm looking for the x value knowing that the y is 25. So I can realize that I have 25 is equal to x to the 5th minus 7. Or add the 7 over, this becomes 32 equals x to the 5th, x must be 2. So now I know a point. I have this point 225. So now I know what the inverse is. I know that f inverse of 25 is in fact 2 for this problem. Because the point 225 on f of x correlates with the point 25,2 on f inverse of x. Now what I can do is I can realize if I have that point, so I now know what f inverse of 25 is, that's 2. So now what I can do to make my life a little bit easier is I can realize, well, I can find f prime of x. If f of x is x to the 5th plus 7, then f prime of x is 5x to the 4th. And what this tells me to do is it tells me to find the f inverse of x, which we just said was 2, and I want to take the derivative of f and sub in that 2. So I want to find the f prime of 2, which is 2, 4, 8, 16 times 5. 5 times 16, which is 80. Yeah, 80. Now that's the derivative of f. I want the reciprocal. That's where this dy dx. So remember that that is dy dx. So the inverse derivative at 25 is going to be the dx dy of the derivative at 2, or 1 over 80. So whatever I get here, I just take the reciprocal. And there's my solution. Now, this is not something that comes up very often. This will be at most worth 3 points on your actual AP test. So you're going to notice I'm going to kind of gloss over these a little bit. I'm not spending a huge amount of time. Again, I'm showing you a process more than an understanding of the actual concept. We can still come up with this with relative ease. So, using the table below, if I want to find the f of 2, what am I going to do? I'm going to go I'm going to go down to the x is 2. I want the f of 2, and I wind up getting 4. It's easy. A little bit harder question is the f inverse of 2. So what this means is that my y is equal to 2. So I want to find out when does y equal 2. When y is 2, I want to know what the x is. So in this case, the y is 2, the x is going to be 1. The derivative of 2, so I go down where the derivative of 2 is, and I find f prime. That's easy, that's 2.8. If I want to find the derivative of the insert when that is 2, I have to realize that I'm looking for when the y is 2. So here's where the y is 2. And I want to find the derivative that kind of connects with this. So when I look at this, I find out that the derivative is 1/4. Now that's not the case. Remember that this right here is dy dx, and this is asking for dx dy, or the reciprocal. So if this 2, when the y is 2, I have a f prime of 1.4. My inverse is 1 over 1.4, and I am done. Whew. For example 3, in any case when I get a problem like this, unless it's a table, you're going to see me draw those 2 really annoying curves, and I'm going to do this for literally every single problem I deal with. I'm going to have a point, it's going to correlate with another point that gets reflected over the line y equals x. This is f of x, who cares what that looks like, this is just an ambiguous f curve. We want to find the derivative of the inverse at 26. So what does that tell me? I have the point 26 comma blank, which means this point is blank comma 26. So what is this right here? Well, that is 26 is equal to x to the 3rd minus 1. add the 1. This is 27 equals x to the third, or x is 3. So now I know what that value is. This is a 3. I can't find the derivative of the inverse unless I know what the derivative of f is, so I have to find f prime of x, which is 3x squared. And I only know the x for f prime, so I'm going to substitute that in, f prime of 3, which is 3 times 3 squared, which is 27. If f prime of 3 is 27, what that tells me is that the derivative of the inverse at 26 is equal to the reciprocal of the derivative at the point that correlates with it on f. At f, this was 326, so the derivative at 3 was 27. 1/27 is my answer. So what you do is you almost turn the problem from the inverse into an f of x problem. You do the regular f of x problem like you would any other problem, and then when you go back to the actual question, you simply take the reciprocal. This gives us really cool problems like this one right here. Given that f and x are differentiable everywhere, g is the inverse of f, so that's the giveaway there, and that f of 3 equals 4, f prime of 3 equals 6, f prime of 4 equals 7, find the g prime of 4. Again, I'm looking at this and I'm going, what do I have? I have an f function, and I have a f inverse function that in this case is my g function. I'm trying to find the g of 4, so this is 4 comma something. So this is something comma 4. I need to figure out what that number is. So I look. When does my y equal 4 for f? I know that the f of 3 is 4. If I know the f of 3 is 4, then I can find the derivative of f at 3, which is 6. And if that's the case, then g prime of 4, which we said is the part that fits here, is the reciprocal of the derivative at 3, 1/6. Closing it out, same exact thing can happen in this problem. If f of 4 equals 5 and f prime of 4 is 2/3, find the inverse here. Again, I'm going to look. I have f inverse. I'm trying to find the point 5 something, which is the point something 5. Well, f of 4 is 5, and f prime of 4 is 2/3. If f prime of 4 is 2/3, then the inverse derivative at 5 is the reciprocal of the derivative at the point that correlates with it, in this case, 3/2. There was a lot that we talked about, and I went through it relatively quick. There was a few examples, but I'm going to expect there to be some questions. Hopefully that was at least something. If you want to try a problem or two, you have some questions, but you will have a chance in class to work on them as well. So don't feel overly stressed to feel like you need to have a whole set of questions done before then. Look forward to seeing you again tomorrow and answering those questions and giving you a chance to work out some of these problems on the board. Have a fantastic day.